So all of you, good afternoon, online, offline. Shrishti, Ashi, Atul, good afternoon, all of you. Good afternoon. And offline students also, good afternoon. Okay, so yeah, so you can ask your doubts on the chat platform that you have, and I'll keep answering your questions. Okay, fine. So we have these relay sessions where we have two entry points where the batches converge. One convergence happens in the topics of geomorphology and maybe even in climatology. And one more convergence happens in population geography. Okay, so we are starting off with geomorphology. So we had one session as a part of orientation on the 19th. Geomorphology. On 19th of July, we had your first session of orientation. So all of you, those who have missed out, it's on the YouTube. आप देख लेना उसको एक बार. The discussion was more around how can you converge your geographic preparation as a part of a timeline. I'm assuming most of you are preparing for 24. And for that, by what time you must finish what all. Okay, it was a small conversation. And then I insisted on to make sure you plan your GS also pretty well. Because this is one problem year after year I face. Okay, you know, if GS is done, option is missing. If option is done, GS is missing. Then you converge karna hoga. I had some quick discussion, not much on that. Okay, aap usko dekh lena uske baad mein. We can discuss something on that lines. Now, apart from that, just for the benefit of those who have joined us for the first class today, we run your sessions in two parts. The first part, approximately about 25 classes, we initiate you. This is more around maps, okay, of the world, which we began in the month of June for some of you. And iske baad, this is the first part. And the second part is what I'm starting now. This is the proper foundation. In the foundation, I'm focusing on your syllabus. And our commitment is I'll finish off about 95% of the syllabus. Okay, though I commit around 85%, but I do a bit more on that. Your foundation course will go on for your 6 months, depends on where all of you have started. So, and then there are certain follow-up assignments. We'll share a table for this also. There is some bit of synopsis writing, some bit of recall for your answers. We take up a workbook session. ये आपके follow-up sessions बाद में होंगे. So right now we are here. Those who have missed this one, I think Nitish, I think we are having the provision to give you the recorded sessions of these classes. We can't have it every time. The last time we had was in the month of June. Okay, jo miss kare hain, I'll see if we are providing that or not. Ajay, are we giving the record sessions for the maps? We are. So it's open for all of you. Those who have not joined this session. Okay, it's no extra fees for this, but I think it gives you a good base to start off your geography proper. Okay? So right now, आपका program ये वाला है. This is where we have started. So you are joining students who have joined us the month of May also, and some of them joined the month of April also. April वाले भी ये किया होगा. May have again done only this much, and those who joined in June, they have done this. And in July, you are doing only this one. This alternate cycles goes on. watch other videos. You don't need other videos. You focus class, that's enough. I did some changes in this batch, in the June batch, because I saw the prelims questions and I felt map is the bigger gap that you have. Baki tum padhai lete hain aapko. Maps is something we cannot do in the regular classes. And I focused on the world maps. India map to hai aapke syllabus ka part hai, but I focused on the world maps. Karan, I know you would want a bit more on that, but we have to maintain a timeline for that. We cannot have it for the entire year. So 20-25 class kafi hota hai. That's good enough. Okay, so you can manage on that. Okay, fine. So let me, yes, Amit. In the last class, I have told you the books you must buy. For the next almost 25 days, we will have geomorphology. The book is this one, geomorphology, ek edition hai. Some of this will have a separate cover also. Ye bhi ho sakta hai cover aapka. The books don't vary much. Pages aage piche honge, two or three pages, but buy the separate book called Geomorphology by Savinder Singh, all of you. Okay? Okay, I can see your suggestions there. Those who began the month of May, you calculate 6 months from there. Those who are starting from month of July, start 6 months from there. This is additional one. So my actual official one starts here. So aap wahin se kar lo, more or less 1 week, 4-5 days ऊपर नीचे, I finish off the sessions. Okay, fine, Aryan, you're welcome. You're welcome. ठीक है, then let's get started now. So your syllabus में, the first unit is geomorphology. So your geography syllabus जो है, broadly 2 parts. Okay, paper 1 and you have paper 2. In paper 1, we have the physical geography, and paper 1 also has a human geography. Physical geography is section A, human geography is section B. So those of you who had joined me in the month of May, okay, so I have taken care of some parts of this topic, population, settlements. We moved on to agriculture. Those beginning from now, I'm starting here. I'm starting with physical geography. Okay, so this is our focus in physical geography. You have 5 units. You have geomorphology. We have climatology, oceanography, biogeography, and environment geography. I gave you one assignment. Last class we met, 19th ko. Those joined us afresh. I said, ek baar syllabus dekh lena, all of you. See the syllabus, write the syllabus down in your own handwriting. Look up the keywords syllabus mentioned here. And I also said, if you can look up your question papers also, the PYQs, the previous year's questions, and do some analysis, whatever you can. Okay, so you need to know your syllabus very, very well. So to start off, I said geomorphology is the first topic I will take. This is the first topic I will take here. And I will maintain this sequence more or less. I'll do geomorphology first. Then I will do climatology. Then I will do oceanography. I will do a part of biogeography. Okay, so yahan tak more or less your syllabus is aligned with the classes. Okay, and geomorphology takes approximately about 20 days to 25 days. Okay, and then of course the rest will follow. Yes. No, I will. Your course will be completed. So human geography bhi karenge, but I'll do it later on, not now. Okay, I'll do it probably starting from maybe month of what? It could be around September end onwards. I'll start with your human geography. Jay Sonwani. Mapping का classes, if you are taking admission, आपको मिल जाएगा portal पे आर्यन. No. Watch the live classes that you have. One suggestion to all of you, because some are beginning now. आपके पास दोनों options हैं. You have both the options. Okay, we have live sessions, and to support you, we also give you the recordings. Okay, my suggestion to all of you is do this. Don't depend on this. Okay, this is one of the learnings you'll have eventually. आपकी actual पढ़ाई live में होगी. Recording we give because all others give. There's a kind of a market dynamics. But those of you, unless you have a very strong reason, maybe once in 15 days आपका class miss हो गया, or you are in job, you cannot do the live classes, you have some other compulsion, तो ठीक है, understandable. Otherwise, those of you go lazy बीच में, कि आज मन नहीं कर रहा है, मैं recording देख लूंगा. That is a terrible strategy you'll have. Those of you depend only on this. I'm not saying impossible है, but वो बहुत बड़ा challenge है. You will mess up. So you must study like आपका आज का class miss हुआ means you have missed it. So study in that type of a mode. Okay, if I miss the class, you must tell yourself कि I can't afford to miss it. So पूरा पढ़ाई, okay, do on the live. I asked one of the students couple of weeks ago the question about are coaching institutes important or not? Okay, ऐसी बातचीत में asking him. The answer that I know is coaching institutes are not a must. A lot of things you can study on your own. And to be very honest, whatever you need, आपको जो भी चाहिए, it's there on the websites. It's there on the YouTube. It's there on the Wikipedia. Whatever I'm teaching is not my creation, not my research. मैं भी पढ़ा रहा हूँ आपको जोड़ के पढ़ा रहा हूँ from this book, from that book, from this article, and more or less that access you have. So can you study on your own? Yes, you can, 100%. Do people studying on their own qualify? Yes, they do. Okay, but the challenge is two fronts. One is maintaining a routine. कि कुछ भी हो जाए, I must study for 2 hours. Okay, whatever happens, I must summarize for 1 hour. Whatever happens, I must have 1 hour or 1.5 hours of current affairs reading. This regularity is what becomes challenging for the examination. When the examination is of a kind where you need to put 1 month or 2 months, 3 months, think of the CAT examination, think of the Bank PO examination. Preparation does not require more than 2 months, 3 months. Even exams like GMAT or GRE, it's not a 2 years preparation. It's basically a 2, 3, 4 months preparation. So for 2, 3, 4 months, it's easy to maintain a routine. But when the routine becomes an affair of 1 year, 2 years, then it becomes a challenge. So the main advantage of you joining a live course is, no matter what, you are part of a regular session. आपको पसंद हो नहीं पसंद हो, बारिश है नहीं है, it's summer, it's winter, it is okay, whether it's cold or not cold, whatever the reason, the class goes on. So that regularity is what's helping you. That's why I'm saying, of the two, live sessions give you the regularity. It's like a discipline you force on yourself. Whatever happens, I'll be in the class at 8 o'clock. Whatever happens, I'm in the class at 10 o'clock. Whatever happens, I will study geography 12 से 2 बजे या 2:30 बजे तक every day. So that regularity is a must. Okay, I think that is where, and plus the engagement. I'm talking, you're asking me, I'm clarifying doubts, and you have a sense of competition here. Not coming to class going to impact you adversely there. So be in class, all of you. Yes, be in class as far as possible. And unless you have a very strong reason, I can't do today's class because some commitment, तो ठीक है, go for the recordings. But this is a very false sense of having content. एक mistake बच्चे करते हैं, किताब खरीद लेते हैं. Okay, it's something of that kind. You have joined a course, you have the recordings with you, but you can't read till you are regular. Okay? So that was initiating the process. So let's begin. All of you can keep your notes and your pen, pencil ready, and you keep writing as I'm discussing. Okay? The first unit is geomorphology. Now, geomorphology is about what? Geomorphology studies the landforms on the earth. What are landforms? Landform, as the word suggests, is essentially a form. A form ka matlab hota hai shape. A form means it has some dimensions. A form means it is a feature, okay, of the land. Okay, geomorphology studies the landforms of the earth. Landforms of the earth, those which are visible and are outside on the surface, and those which are under the surface, The landforms, okay, are shapes of land. Landforms are, okay, features of the land. See, आपका land है. On this land, this is the landform. On this land, this is the landform. On the land, this is the landform. This is a conical mountain. This is a plateau. This is a valley. So any landform is what? It is some feature. Okay, it is some formation. This is a better word. It is some formation on the land, and a formation that has a shape. It could be rectangular, it could be triangular, it could be deep valleys, it can be flat plains. It has a shape. It has some dimensions. You can measure it. Kya height hai, kya length hai, kya width hai, kya depth hai. It has dimensions. Okay. And then I said the landforms are those which are visible. So dikhta hai, what I can see outside the surface. So I can see this. I can see this. I can see this. And then underneath, there are some landforms here. I can't see it. There's some landform here. I cannot see it. These are above the surface. These are underneath. Above surface, okay, these are extrusive. Above surface are extrusive. The inside surface, these are intrusive landforms. Intrusive as in inside, extrusive as in outside. So geomorphology is the study of landforms on the earth, a study of the features and formations on the land. When I say land, the land can be, okay, continent, can also be ocean floor. The land can be the continents. The land can also be the ocean floors. So on the ocean floor also we will have mountains. On the ocean floor also we have valleys. On the ocean floor we can have plains, the depth of the ocean floor. Take all of you. There are extrusive landforms which are outside and the intrusive landforms. Okay, now geomorphology has evolved. It has evolved, and it has different parts. Okay, इसके अलग-अलग parts हैं. One is called as the tectonic geomorphology. One is the tectonic geomorphology. By the way, I hope you can understand कि ये morphology ही लिखा हुआ है. Okay. Slowly, gradually, You will turn to respect your own handwriting also. Okay? The first part is called as tectonic geomorphology. This is everything related to the energy and the processes of the interiors of the earth. Anything related to what's happening inside the earth. Okay, inside the earth, it's very hot. Inside the earth, there is magma formation. Inside the earth, okay, the mantle is moving. So everything that is related to the energy and the processes in the interiors of the earth. The word tectonic hai. The word tectonic, if you can see a relationship or similarity, the word is technique. Okay, tech. Okay, technology. ये वही word है, same root word. The word tectonic means building, कुछ बन रहा है. Technology makes something. Technique is a process of making something. Okay, tech is something that can create other type of substances or products. So the word tectonic is about building. Technology builds. And the processes that create things, they happen inside the earth. So tectonic geomorphology is everything about what's happening inside the earth. Inside the earth, mantle is moving. Inside the earth, molten rocks are moving. Inside the earth, there's something called as convection cells. Something is circulating inside the earth. So whatever is linked to the earth's interiors, we call that as tectonic. इसका एक part ये है. The second part of geomorphology is structural geomorphology. A structural geomorphology. Okay. Now this is about the study of landforms, more in terms of the shapes, study of landforms, more in terms of the shapes, more in terms of their composition. Study of landforms in terms of the shapes, in terms of the composition, in terms of factors affecting those. In terms of factors affecting those landforms. It's about the shapes. It's about composition. What is it made up of? It's about the factors that influence. So factors can be, okay, a river as a factor, temperature as a factor, or winds as a factor, and many other factors. So if I divide the two, it's something like there's some process that happens inside the earth, andar kuch ho raha hai, and that creates something. Study of those processes is called as tectonic geomorphology. Once the landform is made, okay, then I can study, oh, this looks high, this looks low, this is flat, this is hard rock, this is soft rocks, this has maybe silica content more, or this has iron content more. When I study a landform like that, I call that as structural geomorphology. It's something like you're making a building. You have got different phases of making a building. Think of an architect, jo pehle bana raha hai drawings. Then somebody says, let's do construction. Then somebody does the finishing part. Ye alag-alag part of construction hai. The architecture, the design, the actual construction, and the finishing, and the rest. तो वैसे सोचो आप. The earth has landforms. This the earth has landforms. The earth has landforms. Some outside, some inside. One is that this landform is the product of what's happening inside. Whatever is moving inside. whatever the process happening inside. Second is, this one has some composition. This has some shape. This has some factors influencing it. Landform ban gaya, the river is eroding it. Landform is made, the winds are eroding this. Landform is made, maybe the glaciers are shaping this. When I focus on the inside of Earth that makes all of this, I call that as tectonic geomorphology. Once I focus on ki isko chodo, okay, let's study what is it made up of. Let's study the shape of this. Let's study how this changes, not because of this, but some other factor. I call that as structural geomorphology. In your syllabus, you have more of this. You have more of this, you have less of this. Okay. But iska ek part hai, one component of this is, ek to ye ho gaya. Ek aur component hai, is the study of slopes. Study of slopes. This is a big part of geomorphology. The structural geomorphology includes the study of landforms in terms of this. The second is study of the slopes. Now see, what's a slope? Any landform, so imagine this is the landform. Any landform is essentially a collection of small parts like this. This shape is because, this shape kaise bana? Okay, this one part, another part, a third part, a fourth part. You combine all of this together, you have got a shape. So when I study a landform in terms of these segments, this slope is not same as this slope, is not same as this slope, is not same as this slope. So when I study the segments of the face, this is the landform. Iska face, is face ka ये एक segment है, एक part, एक piece है. इस face का ये एक part है, एक piece है. When I study landform in terms of this, I call this as slope studies. Like human body, my hand is one part of the body. And I can study hand in terms of parts like there are cells, there are tissues, there are muscles, there are bones, there are vessels. एक तो है the whole hand in totality. Second is study in terms of cells, study in terms of the building materials, study in terms of the building blocks. I have a wall. Okay, the wall in entirety. The wall is 5 meters high, 20 meters wide. The wall is vertical. The wall has blue color. And then I study the wall is made up of bricks. The wall has bricks. So we see this is the landform. The landform is made up of certain segments of the face. We call each of these as slopes. And I can study the slopes also individually. So go back to our notes here. I said, study of slope is what? The slopes are the facets. The slopes are the segments of the landforms, face. Slopes are the facets. Slopes are, facet ka matlab hota hai piece. Slopes are the facets. The slopes are the segments of the landform's face. The syllabus has this also. In fact, of the two, study of landform alag se and slopes mein, the syllabus has more of this or ye not properly detailed at all. Okay, is pe questions aati hain, but just one question in last 20 years, they must have asked 4 or 5 questions on this. Okay, but nevertheless, we'll see what we can do about how much to cover. Okay, fine. So one part of geomorphology is, I said, the tectonic geomorphology, where the focus is what's happening inside the earth. And the second part of geomorphology is structural geomorphology. It's about landforms and the slopes. And the third part of geomorphology is the applied geomorphology. The applied geomorphology. Applied का मतलब होता है using the knowledge, the understanding of geomorphology for a human development and human purpose. What is this about? It's about using the knowledge, using the understanding of geomorphology for human development, for solving human problems, for exploring resources, for understanding, okay, processes, for understanding processes that can help development. Applied का मतलब होता है, applied is in terms of how is it benefiting, okay, us. So you are using the knowledge, you are using the geomorphology understanding for human development. How can it help me in some ways? For making our cities, construction, building roads, bridges, for solving problems like floods, solving or addressing concerns like landslides. How can I use geomorphology for resources? Mining karna hai, coal fields, iron ore, yes, resources hai. And how can I use it for any type of development? Economic growth, use it for social development, whatever you need. Okay? So these are the three parts of geomorphology: the tectonic geomorphology, the structural geomorphology, and the applied. This is a very important part. Now, increasingly, more and more questions are asked from applied aspects. So I will have a look at the syllabus later on. आप समझ लो what is there first. So I'm summing up. Geomorphology, very loosely said, I said a study of landforms. There are three parts to this. There is a part called as tectonic geomorphology, a part called as the structural geomorphology, and a part called as the applied geomorphology. Your bulk of the syllabus is here and here. And from this, a part has slopes. This is more important. The other part called landforms, okay, not as many questions asked directly. हर साल एक सवाल पूछ देता है 10 mark का, but not something which is a very tricky part. Okay, these are the more detailed aspects: the tectonic, applied, and the slope studies. अरे बताया तो सही आपको. Fine, you maybe join later on. The reference book for all of you is Geomorphology by Savindra Singh. This is a must buy. ये खरीदना ही खरीदना है. And you can have an additional reference is a Rupa publication, Geography Made Simple. इसका volume 1 जो है, it has geomorphology. This can be the additional one, but this is more important. Okay, let's continue. Okay, now some quick basics. Some of you have done GS already. ये पता होगा आपको, a bit of repeat, but that's okay. Okay, we can quickly summarize all of this. About the Earth, I hope you know Earth is the densest body, the densest planet of the solar system. Earth's density is approximately about 5 or 5.5. Okay. Earth का जो interiors हैं, Earth's interiors, they are layered. Earth's interiors is stratified. It's not one single rock. Earth's interiors has layers of this kind. Okay, the innermost layer, the next layer, the next, and so on. So Earth's interiors are layered. Now, this layering thing is a very important aspect. It's a layered aspect hai. This is probably, you keep writing please, it's probably because of how Earth was formed. Why I say probably? Because lot of things are still not very clear to us. That's why I use the word probably. It's probably because of how Earth was formed. There is a theory called as, okay, nebular hypothesis. Hypothesis. Okay. Nebular, N-E-B-U-L-A-R. Hypothesis. This theory says, okay, that Earth, okay, the beginnings was a cloud of dust and gases. How was Earth formed? बहुत सारी theories हैं. One theory says the beginnings of Earth was probably a cloud of gases, the cloud of dust particles, cloud of some, okay, particles we do not even know about. We use a term called the dark matter. हमें पता ही नहीं वो क्या चीज है. Okay, we are looking for it, researching about it. Okay, so it's a cloud of dust of gases, and this cloud is called as nebula. It's called as nebula, or LAE for plural, nebula. And this nebula, the nebula condensed, the nebula cooled and became solid. The process is called as accretion. A process called as nebular accretion. ये जो gas था, for some reasons, it starts cooling, it starts condensing, it becomes solid. It's called as the accretion process. And in this accretion process, what happens is, इसमें होता क्या है? What happens in this is, the denser material will fall inwards, and the lighter rocks, they remain, okay, progressively outwards. The dense material, they fall inside, they fall inwards. Now don't ask why on this. There's a process to this. We will just remember this, that's all. In the nebular formation, the nebular accretion process, the denser material falls inwards. मतलब ये है कि if this is the nebula gas, जो कुछ भी भारी है, heavy है, it'll become the core inside. Then the next layer will be next less heavy. Then I will have next less heavy. Then I will have the next less heavy. So if this is density D1, this is D2, this is D3, this is D4. Inside will be the heaviest part. And then D2 is less heavy than D1. D3 is less heavy than D2. Then D4 is less heavy than D3. It becomes progressively lighter as I go outwards. Okay, yes. Yes, but that's not the direct reason. Our logic says, is asking me, is there a role of rotation? Yes, but not the way we think, because what we know is when rotate something, the heavier one will get thrown outside. What we call a centrifugal force, right? Agar it was rotation alone, the heaviest one should have been outside. Okay, but ऐसा नहीं है, इसमें ठीक उल्टा हो रहा है. Rotation plays a role, but not the way we know it. We'll keep it at this. इसमें बहुत सारा ज्ञान है. कांत का अलग थ्योरी है, लाप्लास का अलग थ्योरी है. Okay, one theory says it was rotating, it becomes slow. One theory says it was not rotating, it starts rotating. So let's not get into those discussions. Okay, you just know this for now. The process called as nebular accretion, in which there is some gas, there is some dust particles, they start to cool, they start condensing, and the denser material, it falls inwards, it becomes the innermost part, and the lighter ones, they arrange themselves progressively outwards. Isko bolte hain, is also called as gravity collapse. It's also called as gravity collapse. As in, because of gravity, the heavier one is inside and the lighter ones are outside. We also call this as gravity collapse. I'm seeing all your comments on your chat. I'm choosing to ignore some of them. Okay, this is my prerogative. Why the sun is not the densest? Okay, the scope of new innovations. What is centripetal force? The density ka unit kya hai? Okay, density ka unit hum nahi le rahe hain because I am discussing specific density in comparison to the water. If water is 1, earth is 5 times denser than water. So hum add nahi karte hain unit. So I'm seeing your comments and your doubts, but I'm choosing what to reply and when. So aap likhiye apna doubts, koi dikkat nahi hai. But no promise to answer all of them right now. Nothing more, Prabjot. Bas itna kafi hai. That's the word called gravity collapse. Okay, in the gravity collapse, the denser parts will go inside. The gravity will force the dense one inside, और जो हल्का रहेगा वो बाहर रहेगा. That's all. So if I have a planet which has layers like this, so now you know, जो अंदर होगा वो सबसे भारी होगा, dense होगा. You go outside, less dense. You go outside, even more less dense. Go outside, even lesser denses. And the outermost layer can be gases here, which in our case is the atmosphere. That's all. Take all of you here. Now listen, all of very important. I am not teaching NCRTs. Okay, NCRT is a very base element. I quickly have to move on towards the graduation level course. Okay? So some things I will tell you may not know, but write it down right now. Okay? And in time you will understand when I take up more conversations. Yes, for now, Monica, gravity collapse is the process of planetary accretion. If I sentence likhenge hum, so gravity collapse is the process of planetary accretion. Correct. What do I mean by planet accretion? मतलब क्या होता है? The planet formation. वो बनता कैसे है? बनता है because of the process called gravity collapse. And this operates for what? It operates for the ancient nebula. Who gave the theory? There are two versions of the theory. One was given by Kant, another one was given by Laplace. Kant theory now is not accepted. Laplace is more acceptable. But like I said, nobody knows for sure exactly what happened. It is still a very large gray area for us. हमें पता नहीं क्या हो रहा है. ठीक है? So we just know that this probably is one of the theories that explains how the planets have been formed. You just know this much, that's all. ठीक है? So our discussion began with this, that our Earth is layered, the Earth is stratified, probably because of the nebular hypothesis. This is probably the most acceptable version why Earth is layered. Yes, correct, Yasir. The dense ones form the inside core and the lighter ones are outside. Yes, fine. Okay, let's move on. Now, for all of us, when we say geomorphology, I said it's all about the landforms, which are on the surface, landforms inside and under the surface, and what are the processes that shape the landforms. Okay, this you understand now. Second, all began with what I said? The process of nebular accretion. All began with the process of nebular accretion. Two things you know now. Third thing, what is the conditions of the Earth's interiors? Give heading. What is the conditions of the Earth's interiors? Okay. So we'll take on facts. Okay, we'll take on facts. First is there is an outermost layer of Earth. Okay, the outermost layer of Earth is called as the crust. My discussion theme is what is the conditions of the Earth's interiors. Andar kya kya hai? What all do we have? Conditions kya hai? So I start the conversation by saying the outermost layer jo hai, Earth I said is layered. Earth is layered. Okay. And the outermost part has some type of properties. Yeah, outermost part. The outermost part is called as the crust. The crust is the lightest. The crust is the coolest. जो crust है वो सबसे हल्का होता है, and it is the lightest, the coolest, and the crust is of two types. The crust is of two types. Two types in what ways? One type is called as the ocean crust. And the other type is called as the continent crust. Earth's crust is of two types. Okay, the oceans and the continents. Okay, so if I draw this is the continent, this basin is the ocean. Another continent, and there is another basin called as the ocean. On this I have got water. On this, I have got water. Okay, the continent, another basin called as the ocean, and this has water. So one of the mistakes we make is assuming that the ocean is extension of this. It is not. Your oceans are entirely separate from the continents. The type of rocks which make up the continents are different from the rocks which make the ocean floor. Okay, the crust is of two types. There is a crust called as continent, one called as ocean, and our important discussion point is that the ocean crust is not the submerged extension of the continents. The oceans, they are not the submerged extensions of the continents. Oceans and their rocks are very different from the continents and their rocks. Keep writing as I write, please. The oceans and their rocks. The rocks oceans mein hai, they are not same as the rocks which are the continents. It's something like my hand and my fingers, and I have the nail. Okay? Yes, the nail is attached to my finger, but does not mean the nail is same as my finger. Okay? There's an extension, but nail is not same as the skin. Kuch variant hoga uska. I have my face, my body, I have my hair. They are extensions, but not the same things. Ye dono jude hue hain, but not the same things. So both are attached. Yahan jude hue, they are attached. But the oceans are not same as the continents. That's one understanding. So if I look at the earth here, so it's a continent, that's an ocean, another continent, another ocean, another continent, an ocean here, and this is what ultimately becomes your Earth's round shape. Okay, and the continents are not same as the oceans. The continents not same as the ocean. This is the first realization. What is the composition difference between the two? Wait, Aman and Deep, please be with me at my pace. You know a bit more of terms? Hold on. 2 class में सारा clear हो जाएगा आपका. Okay, let's go slowly with this process, please. ठीक है? Okay, oceans and rocks are not same as the continents and their rocks. Just for sake of quick comparison, we have the continents, we have the oceans. Continents are lighter, halka hai. Oceans are denser. Continents are thicker. Oceans are thinner. Continents are made up of more non-ferro magnesium silicates. Non-ferro-magnesium silicates. They are made up of more of this. I'm not saying zero of the rest. It has more of non-ferro-magnesium silicates. Okay. Whereas oceans are made up of more of ferro-magnesium silicates. ferro, magnesium, silicates. This is called as non-ferromagnesium, so it's called as NFMS. This is FMS. They are denser, they are lighter, they are thin, they are thicker. ऐसी मैंने बनाया भी है, देखो, drawing. Continents are thicker, oceans are thin. Continents are thicker, ज़्यादा है, oceans are thin. Continents are lighter, they can float like this. Oceans are heavier. If time or condition permits, the oceans can go inside also. I'll come back on that afterwards. So continents are lighter, thicker, okay. And just know this, that the continents may, the common rocks of continents are a rock called as granite, a rock called as andesite. Like ये common rocks हैं. A rock called as diorite. Common rocks of the continents. The rocks of the oceans are, the common rocks of oceans are, remember one name, basalt. इसका एक variation है called as gabbro. Basalt and gabbro are the rocks of the oceans. यहाँ पर, yeah, you have done it. Granite, andesite, diorite. Maybe you can add one more name here. Rhyolite. So 4 names for continent rocks and 2 names for the ocean rocks. Okay. The common rocks of the oceans are basalt, B-A-S-A-L-T, basalt, and gabbro, G-A-B-B-R-O, gabbro. Okay. And for continents, they are granite, andesite, diorite, and rhyolite. Yes, one more property hai. Yes. These rocks, these are relatively more acidic, whereas these rocks are relatively more basic. If you know the pH value, others who don't have a science background, okay, just write the term, that's all. Very elementary, ये school वाला science है. But you forgot, no problem. Hemant, okay, no extra word right now, just hold on. Let me allow to develop on this slowly, gradually. Okay, our discussion point was, I'm revising for all of you. I'm discussing point was that Earth ka conditions kya hai, interior conditions kya hai. So I began with the outermost layer. Outermost layer of Earth, I said, is a layer called as the crust. The crust is the lightest part, the coolest part, and there are 2 types of crust. Ek ocean crust hai and the continents. And then I said, this is how they're arranged. Think of North America, Atlantic Ocean, Pacific Ocean. Think of Eurasia, Atlantic Ocean, Pacific Ocean. The alternate hai. Land, water, land, water. The land part is continent, is the oceans. In geomorphology, I study both the landforms of the continents and the landforms on the ocean floor. Both are part of geomorphology. Okay, plus I said, the 2 types of rocks are different. The oceans are not extensions of the continents. ऐसा नहीं है कि continent ही डूब गया है पानी के अंदर, ऐसा नहीं है. The 2 have different type of composition. The two have different type of properties in terms of rocks, in terms of how they behave, in terms of the chemical composition, in terms of physical properties. They are dono alag hai. Okay. And how are they different? I gave you this table. The continents are lighter. The continents are thicker. The continents are more non-ferromagnesium silicates. These type of rocks are these, and they are acidic. How light? Continents average is about 2.5 density. Oceans ka density hoga 3.5 density. And how thick? Oceans are generally about 1 kilometer thick, and sometimes they can also be 3 kilometers thick. Yeah, not common, but they mostly are only 1 kilometer thick. The continents can be 30 to 60 kilometers thick, and in some places they can be as much as also 80 kilometers also. The thickness of the oceans is generally about 1 kilometer thick. Sometimes they can be even 3 kilometers thick, but still 1 and 3 is far less than 30, 60, 80. The continent generally are about 30 to 60 kilometers thick. It generally hota hai. In some places, they can also be as much as 80 kilometers thick. But that's fact. I would have come back to, but for now. Okay, Pravash, I'll enter that domain now. Likely all of you fine here? Okay, fine. Now, this is miscellaneous. This is extra. Syllabus में नहीं है. अगर पता है तो अच्छी बात है. Okay. Now, I'm discussing something about minerals. They want to ask you this question, but if you know this, it's nice. So let's say, maybe in a box, once I'm done with it, you note down some facts. Okay? So, minerals are naturally occurring compounds. Okay, they are naturally occurring compounds. Minerals are the building blocks of rocks. They are naturally occurring compounds, the building blocks of rocks. They are generally crystalline. This word means they have some structure. Uska angular structure hota hai, geometric shapes hote hain. For now, just know this, that they are generally crystalline. Okay. There are different groups of minerals. We can have oxides. We can have sulfates. We can have sulfides. We can have silicates. Okay, silicates. The compounds, oxides, oxygen hai. Sulfate, if you know the radical, SO4, 2-. Sulfide is sulfur, 2-. Silicates is a bit more longer formula. Okay. Oxides like iron ore is oxide. Okay. It has oxygen component, 2-. So there are different groups of. We can have carbonates. Yes. We can have carbonates, CO3, 2-. Okay, these are the compound formulas hote hain. Okay, so there are different groups of minerals in the outer layers. Next point, in the outer layers, silicates silicates are more common. But remember, in general, silicates are found in the entire earth. In the outer layers, bahar ke layers of the earth, in the outer layers of the earth, silicate type of minerals are more common. But important point ye hai that silicates are found throughout the earth. Silicates are found throughout the earth. So अगर question पूछेंगे आपको कि tell us the most common forms of minerals. Oxide is very common. Okay, silicates are very common, but silicates are more common in the outer layers. Silicates generally are a bit more lighter. Silica, like sand, halka hota hai thoda sa. Silicates are more common. Now, some of the common silicates, you must know the names, okay? And don't bother about too much details. Common ones are quartz, feldspar. फेल्डस्पार का ही एक और फॉर्म है ऑर्थोक्लेज एंड plagioclase. One forms of feldspar. Then we have muscovite, we have biotite, we have amphibole, pyroxene, and we have olivine. These are the main silicate group of minerals. These are the common silicate group minerals. Quartz, feldspar, okay. One form called as orthoclase, CLASE. One form called as plagioclase. Okay. Muscovite, if you know about something called mica. Mica suna hoga aapne. Mica is a mineral mining. Okay, mica. एक है biotite. And these three, amphibole, pyroxene and olivine. ये जो हैं, these four, these are lighter and they're hard and they are light in color. Okay, and they are relatively more acidic. इनका property है. They're light, हल्का होता है. They're lighter. They're harder. They are light in color. Color is grayish, yellowish colors, and they're relatively acidic. ये जो तीन हैं, these are darker. These are denser. These are relatively basic, and these also are relatively softer. These three. These properties you must remember, okay? Amphibole, pyroxene, olivine. They're dark in color. They're dense. ज़्यादा भारी होगा. They're denser. They're relatively more basic and relatively more softer. ये hard है. हल्का है लेकिन hard है. This is heavy but it's softer. These four, these are the non-ferromagnesium silicates, and these three are the ferromagnesium silicates. It's a transition one. Biotite मैंने बीच में रखा है. It's a transition one, but it is more like this. Biotite is a transition mineral. ये बीच में आता है. But it is more like the non-ferromagnesium silicates. Yes, Rupesh, correct. Biotite is a transition mineral. ये बीच में आता है, transition mineral, but it is more like the non-ferromagnesium silicates. Now, a quick discussion on what are minerals and what are the rocks. Most of you are confused here. Minerals are natural compounds. Rocks are mixtures of minerals. Minerals are definite in property. They'll have a very specific melting point, boiling point, a very specific composition hoga, formula hoga, because they're compounds. They have definite properties in terms of whatever. But rocks, because the mixtures हैं, they have got no definite properties. The granite of maybe Madhya Pradesh is not same as granites in parts of Telangana. Marble of Jabalpur, not same as marble of the Aravalis, not same as marble found in Italy. Sandstone, alag-alag jagah alag-alag hoga sandstones. So rocks like sandstone, rocks like granites, rocks like basalt, they are mixtures. They will not have the same properties. They'll vary hoga. But minerals are definite. They have got single formula. And rocks are made up of minerals. Remember this. Rocks are made up of minerals. Examples of rocks. Granite is a rock. Basalt is a rock. Sandstone is a rock. Limestone is a rock, and so on. Or minerals, so we bataya aapko maine. We have got silicate group of minerals, carbonate group of minerals, sulfide group, and so on. So quartz, feldspar, orthoclase, plagioclase, biotite, muscovite, amphibole, pyroxene, olivine. ये सारे minerals हैं. Okay? Minerals are compounds. Minerals have definite properties. Minerals are the building blocks of the rocks. Rocks के formula same नहीं होते हैं. Is it okay, all of you? Rocks are different from the minerals. But one more point here. The term minerals, this term minerals is used in two senses. One is the compounds called minerals, और एक है the resources called minerals. ये दोनों अलग है. We say no, iron ore mining. Iron ore is a mineral of India. Sand is a minor mineral of India. Okay, minerals like oil is mineral oil of India. Okay, but वो जो mineral है, that's in terms of resource. These are the commercial resources, not same as this. For example, coal को हम बोलते हैं mineral fuel, but in reality coal is a rock, not a mineral. Have we got the point here, all of you? Like we say bauxite. ये term सुना आपने bauxite? Bauxite is not this mineral. This means they are compounds. Okay, bauxite is some rock from which I get aluminium. So this mineral is more in terms of resources. जो हम mining करते हैं, mineral and the word mining. Okay, I'm mining. ये अलग है. This is an economic resource. From this I get other compounds. But this is in terms of chemistry. This is a compound. Both are not the same. Example बताया मैंने आपको, coal. Coal is considered as a mineral fuel. But actually coal is a rock, not a mineral. Is it okay, all of you? Yeah, bauxite has alumina from which we extract aluminium, correct. Like hematite. So आपने hematite सुना है? Okay, that's a compound. Hematite is a mineral. Okay, Fe2O3. Okay? So this is not same like sand. Sand is considered as a minor mineral in India, but not like this. It's in this sense. Otherwise, sand is essentially sediments, which are disaggregated ones. Yeah, fine, correct. Marble, no, marble is a rock. Marble is a rock. हम जब mine कर रहे हैं, I can say marble mining. Okay, so marble is a rock like a mineral resource, but it's actually a compound. So it's actually a rock, not a mineral. ठीक है? So ये दोनों में difference है. The mineral I use as resource is not same as and I'm talking about what? This is all compounds. This one is all compounds, which are natural occurring. ठीक है? So now go back to our conversation. Our discussion was that the continents have more of non-ferromagnesium silicates. का मतलब क्या है? They'll have more of quartz, they'll have more of feldspar, they have more of orthoclase, they have more of plagioclase. And this means they are more of amphiboles, they are more of pyroxene. The oceans are made up of this. Okay, the continents are made up of this. These are lighter, less dense, they are harder. These are heavier, okay, these are dark in color, and they are softer. Akanksha, क्या मिस किया आपने? The word mineral, I repeat, is used in two ways. एक जो common term use करते हैं, mineral mining of India. We have laws on how minerals can be mined. That mineral is the resource wala, but that is not the compound every time. Like say, have you heard about something called as sand mining in India? Heard about granite mining in India? So in our list of minerals, sand bhi mineral hai, granite bhi mineral hai, Kadapa rocks bhi mineral hai, bauxite bhi mineral hai. Okay, but they are not in terms of chemical composition. The minerals, like a generic word, any resource we take from the earth's surface is a mineral. Okay, so ye alag mineral hai aur ye alag mineral hai. I am discussing this one, not this one. This will come afterwards. The rocks and the minerals of India. Economic sense mein aayega baad mein. All fine, all of you? Any questions here? Any doubts here? Okay, fine. Let's move on. So about our theme of discussion was, I'm discussing what is the composition of the earth. What is the conditions of the earth? Under conditions, I have discussed the first layer called as the crust and some terms around the crust. The next one, this is our first discussion. In minerals को आप एक box में डाल देना. Okay, it's like a separate discussion, but keep in box. The second is the pressure and the density conditions. The pressure and the density conditions of the interiors. Under conditions, पहले बताया मैंने, outer layer are oceans and continents. I'm done with that. The second discussion is the pressure and the density conditions of the interiors. Okay, so in this, now I know better that as we go deeper, the rocks and the minerals, they become denser, they become more heavier. Why? I explained that idea called as gravity collapse. When Earth was forming, what was denser fell inside, and what was lighter, it stayed outside. Okay, so as I go deep inside, the rocks and the minerals, they become denser, they become heavier. Essentially, with depth, density of the layers increases. With depth, the density of the layers increases. Okay, the inner rocks, okay, the layer is called as the core layer. Okay, this is the most dense. The inner rocks, they call the core layers, C-O-R-E, core layers. These are the more dense. Okay. The question is, why? Why as I go inside, it becomes more and more dense? One reason is the pressure, because I'm applying more and more pressure. Okay. So imagine this is the outermost surface. I go inside. This is very, very dense. Okay. Why? Because this is having the weight of all of this. Can you all imagine here? This pressure kinds of compresses it. Okay, we call this as pressure freezing, because the pressure, something has become more dense. Okay, so why more dense inside? Why? Because of the high pressure inside. Because of the high pressure inside. Okay, the outermost layers, the density had 2.5. The oceans have 3.5. Go inside, the rocks here can have density of 4. Come here, they can have density of 7. Come here, almost 9. Or under aate, they can be as much as 13 density, very high. Outermost layer continents, 2.5. The oceans are 3.5. These are the rocks of the mantle rocks. 4 hai, fir 7 hai, fir 9 hai. I go inside, the density is as high as 13.5 density hai at the core inside. Why? The reason is, I said one is because of increasing pressure. Okay. But then we say, this is not the only explanation. Okay. Because dekho, when you compress something, you can't compress it infinitely. Okay. At some point, you can't compress anything. Think of water. Can water be compressed? If I apply pressure, can water be compressed? Yes or no? Yeah, nobody from science background? Can water be compressed if I apply pressure? No. And that's the basis of the whole theory called as hydrostatics. Like you have got machines. Doesn't work. Okay. We've got machines that work on hydrostatic pressure. You apply some pressure here, something can be lifted. Water by nature is incompressible. You can't compress water. Jitna aap dal do pressure, you can't compress it. So there's a limit to how much something can be compressed. Okay. So even if I have weight here, aisa nahi hai, because of weight, it can keep on getting compressed. Not always. Beyond a limit, you cannot do it. The more important reason is the composition. इसके एटम्स ही ऐसे हैं, इसमें एलिमेंट्स ही ऐसा है, इसमें कंपाउंड्स ही ऐसे हैं which are more dense than these rocks and these minerals. Okay, like say these layers have, I said, non-ferromagnesium silicates. These rocks have more of ferromagnesium silicates, and these have more of iron and nickel, which are very, very dense. So why does density increase with depth? Pressure is right, not wrong, but that is not the best explanation. The bigger reason is the composition. What is it made up of? Write down. Increasing density with depth. Increasing density with depth is partly because of increasing density with depth is partly because of the pressure, is partly because of the pressure, but more importantly, it is because of the composition of the layers. It's because of the composition of the layers. Next point, with increasing depth, the type of rocks and minerals are such, with increasing depth, the types of rocks and minerals are such that their density is higher, are such that their density is higher. Okay. For example, the outer layers, have lighter, outer layers have lighter silicates, like quartz, like feldspar. Outer layers have lighter silicates like quartz, like feldspar. Next, as we go deeper into the mantle, there are heavier silicates. Like olivine. Heavier silicates like olivine. In the core, next point, in the core are heavy metals like iron and nickel. In the core are heavy metals like iron and nickel. Iron ka weight hai 13.5. The atomic weight of iron. 13.5. Is it okay, all of you? So why is the composition more dense here? Because यहाँ पे जो rocks हैं वही dense हैं. Why these are lighter? Because these have rocks, minerals which are lighter. And the next question is, why did the heavier ones end up here and the light ones are here? That's a nebular accretion. Is it okay, all of you? Write down. This arrangement, next point, this arrangement of denser minerals and rocks deeper inside. This arrangement of denser minerals and rocks deeper inside. Is because of gravity collapse. Is because of the gravity collapse and the nebular accretion process. Gravity collapse and the nebular accretion process. Okay, so our conclusion point, very important point here is, ये जो compression है because of pressure, इसके limits हैं. Beyond a point, you can't compress anything. You can't explain the density only because of the pressure. That's one reason, fine, but that is not the best reason. I will read out a passage from your textbook. I will want that you bring your book to the class, all of you. Okay, when I read, you also can refer and underline. ठीक है, आप लिख लो अभी आप लोग, or just have a look. Just a minute. Something I repeatedly tell all of you, you cannot study without your books. Okay, the notes are never enough. Remember this. Anybody saying this, okay, is misleading you or misguiding you. आपको किताब खोलना पड़ेगा, and I'll help you in what to read. Don't read the whole chapter, okay? This is chapter number 5. The textbook is geomorphology. Okay. Chapter 5, in my book, it is page 105. It could be around that. देखें आप कौन सा page है? 104, 105, whatever. ठीक है. Okay. Now there is this discussion on density of the earth. पहला page में ही है. Earth's interiors. Density. Density, I said, यहाँ लिखा हुआ है, देखो. That crystalline rocks density ranges from 3.5 at different places. The average of the whole earth is 5.5. You go inside, okay, inside the core, 11 hai. You go further, 13.5, and just remember this. Like average of the core is 11, okay, because core ka hi do part hai. But remember, inside the inner core, it's about 13.5. Remember that. Okay. The question arises, what is the reason for very high density of the core? Previously, it was believed that the very high density of the core was because of the heavy pressure of the overlying rocks. This was thought earlier. Why is the core so heavy, so dense? Because of the pressure of the overlying rocks. Okay. It is common principle that the pressure increases the density. Thus, very high density of the core of the earth is due to, very high density of the core of the earth is due to very high pressure prevailing there because of the superincumbent load. This inference is proved wrong because pressure beyond a point will not help. Okay. There's a limit in each rock beyond which the density of that rock cannot be increased in spite of increasing pressure. The very high density of the core is not because of very high pressure prevailing there. It is because of the intrinsic composition, is because of the metallic material present. Okay. The experiments have revealed the core of the earth is made up of, जो composition है, of iron and nickel, and therefore they have whatever. Is it okay, all of you? So textbook reading has to be very, very selective reading. And reading these passages helps you some bit of understanding better. हम पढ़ा रहे हैं आपको, and I'll keep telling you what to read down. So go back to your notes, okay, back in your room, आप पढ़ें उसको, then open the book and see what passage there's. And in the notes, write down the page number also. So in your book, probably page 104, 105, whatever book you're having, okay, that explains why the interiors are dense and heavy. Okay, all done? So that's one conversation. The third one. First discussion kya tha, if you remember? First I discussed is the outer layers, the continents and the crust. The second I discussed was the density of the interiors. Third, I'm discussing the temperature pattern of the interiors. The heading I have is the conditions of the Earth's interiors. We have discussed the density, now come towards the pressure. All keeping pace with me? Aap likh pa rahe hain, all of you? Some of you maybe will take some time to get used to my speed. Okay, but this speed is actually less speed, okay? In time, I'll pick up speed. And one reason is I must finish a course also and tell you something more also. Okay, otherwise ये सब discussion रह जाएगा. These conversations ना आपको बताया जाता है GS में, ना आप खुद पढ़ेंगे और ना NCERTs में है. Okay, so it's like, you know, if I am under pressure and you can't keep pace with me, तो मैंने कंटेंट को काट देना है, फिर आपको पता भी नहीं चलेगा मैंने क्या काट दिया. Okay, so cooperate with me. You all will learn. First 1 week, 10 days, you have a problem, but thereafter you'll understand. ये सब तो ऐसे ही है, अब ऐसे ही पढ़ना पड़ेगा. पैसे दे दिए, फंस गए हैं, पढ़ो अब. Don't give up, guys. The people who do keep pace, and I help you when I write here. Okay, because then you know that my speaking speed is matching my writing speed. तो आप भी लिखें मेरे साथ में. And don't write looking at the board. Write listening to me. Looking at the board will take you more time. Okay, then you are into a different science called as study of ancient scripts. Okay, so now we're discussing the temperature conditions of the Earth's interiors. Of the Earth's interiors. The first fact is, okay, the interiors are hot. Inside the Earth, it's hot. Why is it hot? There is internal heat. Is heat का source क्या है? Partly it is the radioactivity. There is fusion reactions going on. There are fission reactions going on. We have got radioactive material inside. Think of uranium, it can disintegrate. The source of heat is partly radioactivity. And we have something called as the residual gravity heat. ये वो heat है which was in the nebula itself. And when the nebula has become solid, some amount of heat has escaped, but some amount of heat remains. We call this as the residual gravity heat. Okay, so this heat, this is sourced from the ancient nebula that was cooling and solidifying. The residual heat is sourced from the ancient nebula that was cooling, that was becoming a solid, it was solidifying. Okay. The nebula has cooled, but some heat remains. Over the billions of years, ये nebula ठंडा हो चुका है, but even now, some amount of heat remains. That's why we call this as the residual heat. We call this as the residual heat. Yes, yes. इसी heat को बोलते हैं, you're right. It's also called as the primordial heat. Good. Primordial का मतलब है the earliest times, the most ancient times, when there was no planet, there was no solar system. The heat पहले था, it's called as the primordial. the primordial heat. Okay, so Earth's interiors are hot, partly because of radioactivity, partly because of the residual gravity, residual nebular heat, जो अभी भी remain होता है. Next point, third point. In general, write down, in general, the temperature patterns are not even inside the Earth. In general, the temperature patterns are not even inside the Earth. Are not even inside the Earth. Next, for the first few kilometers from the surface, for the first few kilometers from the surface, Earth cools at around 2 to 3 degrees. 2 to 3 degrees every 100 meters. For the first few kilometers, the Earth cools at, sorry, not cools. I'm sorry, warms. Not cools, it warms. Earth warms at rectify karo, please. Not cools, warms. Okay, for the first few kilometers from the Earth's surface. Agar ye surface hai, okay, you go inside, it becomes warmer, it becomes hotter. So first few kilometers, for every 100 meters you go, it becomes hot by 2 to 3 centigrade. Next slide down. Beyond 10 to 15 kilometers, next point, beyond 10 to 15 kilometers, there is no pattern as such. Beyond 10-15 kilometers, there is no pattern as such. Next point. Tectonically active zones of the Earth. Next point. Tectonically active zones, where there is some interaction going on. Those areas have some tectonic interactions. I'll talk about afterwards. You must have heard about the plates colliding, the oceans are subducting, the mountains are forming. Jahan par ye activity chal raha hai, the locations where there is tectonic activity going on, the temperatures can exceed 1000 degrees centigrade. At zones that are tectonically active, the temperatures can be 1000 degrees centigrade. Like think of under the Himalayas. This is the area of activity going on. Okay. Think of under the Rockies mountains, under the Andes mountains, jahan par trenches hai. Okay. So when I say tectonic active zones, areas which have active mountain building, areas which have subduction, okay, areas where there is plate movements at locations of active mountain building, at locations of subduction, at locations of plate movements, the temperatures can be as much as 1000 degrees centigrade. Next one. Okay. Inside the mantle, at depths of 600 to 700 kilometers, inside the mantle at depths of 600 to 700 kilometers, the temperatures can be around 1500 to 2000 degrees centigrade. It can be around 1500 to 2000 degrees centigrade. Next, at the core mantle boundary, at the core mantle boundary, core mantle boundary, it's approximately around 2800 kilometers from the surface. The temperatures can exceed 3000 degrees centigrade. At core mantle boundaries, the temperatures can exceed 3000 degrees centigrades. And at the core and its interiors, temperatures can be more than 4000 or 5000 degrees centigrade. At the core and its interiors, the temperatures can be more than 4000, more than 5000 degrees centigrade. Uh, 15, Ria. Okay. At depths beyond 10 से 15 kilometer. Okay. The temperatures are no longer a pattern. फिर वो vary करेगा. So if this is the earth, अगर ये earth है, okay, and think of this as the first 10, 15, okay, इसके अंदर में it's approximately 2 per 100 meters. इसके beyond, it's all random. Wherever we have tectonic activity going on, the temperatures can be more than 1000. At depths around, okay, 500 kilometer, 700 kilometer, here temperatures can be around 1500 से 3000. If I come to depths of around 2800 kilometers, it's called as the core mantle boundary. इस boundary पे temperature होगा approximately 3000 और इसके अंदर में it's around 4000 to 5000. Okay, so remember this pattern, this, okay, this temperature at the boundary, okay, ये 2000 है. This is the boundary, core mantle boundary, and inside the core. Okay, so there is a passage in your textbook. Just give it a good quick reading. Okay, back in your room. Page in my book, it is 106. आपका 105 या 4 जो भी 6 होगा. Where this ends, the ends we have a section called as temperature patterns. Page, आप लिख लो page. Back in your room, go back and read it. Just about 1.5 columns, ज़्यादा भी नहीं है. Okay. Okay. So the temperature increases from the surface of the earth downwards. 203 for 100 meters. Okay. Thereafter, okay, which are tectonically active zones. It's around 1000 kilometers. You go inside. Okay. Then there's a summary here. Next column में यहाँ एक summary है. The summary is what I'm discussing. Okay. So 1000 at the depth of 400, 700. Okay. It's 1500 से 19. I gave 2000 here. At the mantle and core boundary, it's around 3000. Okay, more than that. And inside the core, okay, 5000, 4000. What I've done is I've taken convenient round numbers. 5000, 3000, 2000. You don't need to know exactly 4300. You keep track of the broad, okay, trends. Satyam will not enter those discussions. Okay, just write radioactivity, that's all. Okay, so what is, यहीं पे passage एक है, the generation and transfer of heat from inside. Okay, generated through the disintegration of radioactive minerals and conversion of the gravity force into thermal energy. ये मैंने तो बताया आपको. This is the gravity collapse, nebula accretion, and radioactive. More important source of heat. It happened 4.7 billion years ago. Okay, and so on. Don't go beyond this. You don't need it. Okay, so you must read maybe main page is page 106 in my book. आपकी book में शायद 105 होगा या 107 जो भी होगा. This one page has temperature and it has the pressure patterns and density patterns. This page. Okay. Fine. Let's move on. So I'll take few more minutes more. So I was discussing the conditions of the earth. One is the continent and the ocean discussion. The second one was the density. Third one was about the temperature. The fourth one is about the composition and the layering in detail. Most questions are here. Okay. The composition and layering of the Earth's interiors in detail. Okay. Now, so you can give a heading. Layering of the Earth. Layering of the Earth's interiors. So the first point here is Earth is not a single rock. Earth is not a monolith. Earth is highly heterogeneous and Earth is layered. Earth एक rock नहीं है. Okay, Earth is not a monolith. Earth is not a single rock. Not a monolith. Earth is heterogeneous. There's a lot of diversity in what it is made up of. There's variety of rocks. There are variety of minerals. There is much diversity of the state of matter. कहीं पर solid है, कहीं पर liquid है. Okay, it has heterogeneous composition and Earth is layered. And I told this to you that this layering is related to Earth's nebular accretion process. ये मैंने बता दिया था आपको. Earth's layering is because of the nebular accretion process. Okay, now there are two ways of studying Earth's layered structure. There are two ways of studying Earth's layered structure. One is on the basis of composition in terms of minerals, in terms of rocks, और एक है in terms of relative rigidity or relative hardness. There are two ways of studying Earth's layered nature. One is in terms of the composition. What is it made up of? What type of minerals and what type of rocks? And second is in terms of hardness, in terms of rigidity. ये दो अलग scheme है. There are two different schemes. It's like, I can group the class in terms of maybe your education background. I can group in terms of maybe the language you speak. I can group in terms of a gender also. The same earth, I can divide into layers in different ways. One is on the basis of composition, what is it made up of, and the associated properties. And the second is in terms of how hard or rigid the layer is. This scheme, it divides Earth's layers into the outermost crust. In terms of the outermost, के बाद में the layer called mantle and the layer called as the core. This is what most of us know: the crust, mantle, and the core. This includes the concept of lithosphere. The layer below this is called as asthenosphere. The one below this is called as the mesosphere, and the deeper part is called as the barysphere. Okay. The mantle is something like mesosphere. The core is something like the barysphere. And the crust, okay, exactly same nahi hai, but related hai. I'll come back on it afterwards. In fact, the mantle also includes asthenosphere. The mantle also partly includes lithosphere. ठीक है? So crust और ये same नहीं है. There's some difference between them. So these are two schemes. ये दो अलग scheme है. Okay, in terms of core, mantle, and crust, in terms of lithosphere, asthenosphere, mesosphere, and the barysphere. Before I tell this to you, okay, some of the older schemes in Earth's internal differentiation. कभी पूछा नहीं है, but nice if you know this. Some of the older schemes in Earth's internal differentiation. So this is what we know. हम पढ़ेंगे detail में. I'll do these two. But you must also know some of the older schemes, okay, which are the roots of what we know today. There are 3-4 schemes. We have the outer layer. We have the middle or the intermediate layer, and we have the inner layer. We have a scheme given by Arthur Holmes. We have a scheme given by Daly. We have a scheme given by Edward Suez. And we have one given by Van der Gratch, Van der Grat. So 4 schemes of Earth's interiors: Arthur Holmes, Daly, Edward Suez, Van der Grat. And this is what most of you know. Suna hoga aapne. The outer layer is called as the sial, the beach wala called as the seema, and the inner one is called as the knife. Most of us know this, part of school discussions hai ye, but the old scheme hai, which is not the one that I use today, given by Edward Swiss. The outer layer is sial, S-I-A-L. This is the lightest layer. This has a density of around 2 to 2.5. Okay. The seema layer is, sial is largely the continent layer. The seema is the ocean layer, density of about 3. And knife is the core, density of more than 11. This is the densest. This is the densest. And write this down. The sial layer, usi mein add kar lo. Don't add separately. The sial layer, this is approximately around 60. That's what Edward Swiss said. About 60 to 300 kilometers ka thickness. Edward Swiss says. And this is up to 2,000 kilometers. A knife is thereafter. Knife has a diameter of 7,000. It has a diameter of 7,000 kilometers. Just know this much facts, that's all. Sial is the lightest one. Density is 2. Sial are the continents. And the sial thickness is about 60 to 300 kilometers, the thickness of the sial. Okay. The intermediate layer, the middle one layer, is a seema layer. Density of 3, 3.5 density hai, up to 2,000. And this makes up the oceans. And the knife, the deepest part, jo core hai, is density more than 11. And it has a diameter of 7,000 kilometers. Okay, that's what Edward Swiss said. Now, what did Arthur Holmes say? Arthur Holmes said that the outermost layer, he called this as the grand diorite layer. He called this as the grand diorite layer, as in granite and diorite, these rocks hain. The intermediate one he called as amphibolite layer, and the deeper parts he called as the echolgite layer. The grand diorite layer, the amphibolite layer, and the echolgite layer. The grand diorite, he said, is the first 10 to 12 kilometers. Okay. The amphibolite, it is below the grand diorite. It has a thickness of 20 to 25 kilometers, and the rest is echolgite. E-C-O-L-G-I-T-E. The rest is the echolgite. Okay, that's Arthur Holmes' ideas. The next is Daly. So Daly says, the first 1,600 kilometer, the first 1,600 kilometer, he called this as the outer silicates. Call these as the outer silicates. These are lighter. These are lighter, and they have density of around 2.5 to 3. The outer silicates, they are lighter. They have density of 2.53. The next he said is the next 1300 kilometers thickness, and this has a density of about 4.5 to 9. 4.5 to 9. And then we have the inner silicates. Yeah, sorry. पहले में क्या है? 2.5 to 3. हाँ, the first 1600, yes. उसके बाद में next 1300. पहले 1600 खत्म हो गया, उसके बाद में next 1600 kilometers. Sorry, 1300 kilometers. This is the inner silicates. This is the inner silicates. So what remains behind this, below this? And this has a diameter of 7,000 kilometers, and it has a density of approximately 11. The density of approximately 11. The outer, the inner, the middle layer, that's all. ऊपर लिख दिया ना मैंने, outer layer is outer silicates, the inner silicates, and we have the middle layer. Now come to the Van der Graat's model. Quickly finish this off. Now this is more close to what we know. So what he says is the outermost layer, he calls this as again the outer silicates. This is the outer silicates. The outer silicates, this is about 60 to 80 kilometers, and this has a density of about 3 and less than 3. Okay, this makes up the continents. The layer is outer silicates, density about 3. Okay, 60-80 kilometers thick, and it makes up the continents. And he says that this layer is absent at locations of oceans. This is absent at locations of the ocean. Think of Pacific Ocean. वहां पर ये layer नहीं है. Absent at the locations of the oceans. Okay. जो intermediate layer है, there are 2 layers in this. In the intermediate layers, there are 2 layers. One is the inner silicates, and the second is the layer of mixed silicates. The layer of mixed silicates. ये 2 layer हैं that make up the middle layer. The inner silicates, this is approximately from 60 kilometers to about 1,000 kilometers. Under this, 60 से below 60. Okay, from 60 to 1,000 kilometers का ये thickness है, the inner silicates, and the density is approximately around 3 to 4.75. Density of 3 to 4.75. Okay, and the mixed silicates, हैं, write down, this has silicates along with some metals. Silicates along with some metals. This extends from 1,000 kilometers to about 2,900 kilometers depth. From 1,000 उसके नीचे आ गया, सबसे ऊपर ये रहा, उसके नीचे ये है, इसके नीचे ये वाला लेयर. Okay, so if I draw this in terms of diagram, Earth here, the first layer is this, the second layer is this, the third layer is this. So this is approximately up to 60 kilometers. यहां से यहां पर up to 1,000 kilometers. यहां से यहां तक about 290 kilometers. This is the outer silicates. This is the inner silicates, the mixed silicates. Okay, and the density of this layer is approximately 4.575 to 5. 4.75 से लेकर 5 तक है ये वाला. 5, and then this is the core. This is the core. This is beyond 9 kilometers core, and this has a density of about 11. It's made up of pure metals. It's made up of pure metals, the most common being nickel and iron. It's made up of pure metals, nickel and iron. So our modern concept is more like this. That's why I must ask you to know this name, Van der Graat's model. This is the closest we have to the reality. Tell me. Depth, कितने गहराई है? Density is कितना matter है? How dense it is, कितना भारी है? Okay, so if ये surface है, how deep you go, इस kilometers में होगा. और ये कितना भारी है, ये कितना भारी है, how dense it is, ये अलग चीज है. Depth is in terms of distance, and this is a different parameter altogether, how heavy it is. Dailies, okay. Look up, please, all of you. Daily, the first 1600, uske baad mein, the next 1300 to 1500, and beyond that. So if this is the Earth, the first, ये 1600 किलोमीटर, उसके बाद ये जो thickness है, this is about 1300 to about 1500. उसके बाद ये diameter जो है, this is 7000. The Dailies layering. The first 1600, the next, ये thickness की बात हो रही है. The thickness is 1300 से 1500 thickness, and then you have the diameter of 7000. This is Daly's scheme. Okay, now all of you, for the next couple of classes, you'll have a lot of facts being pumped onto you. Okay, there is not much to understand in this. Understanding is there are layers. Understanding is that the rocks are different in composition. The understanding is there is a density segregation because of the nebular process. Baki sara facts hain. You must remember this. What I want is, whatever I've taught till now, summarize that into one page. Use diagrams, use schematics, use bullets, what we call a synopsis. Some of you have been with me for some time, you know this method. Others, you must try this. आप करके लेके आओ tomorrow and we'll see. Okay, your mentors can help you, okay, in discussing that. Fine. So that's for today. We continue tomorrow. And tomorrow, please bring your book with you, please. All of you.
This one.
Sorry?
This one.
Either of them. All of them have different covers, but won't matter much. So what's in the market, the latest edition, buy that one. Yes. Which one? Buy this one. उसमें सब कुछ होगा और सब details नहीं होंगे उसमें. Yeah.
Delhi.
In Delhi.
Yes.
Yeah. What about it?
Radius of Earth is 60 and 60.